Lee. Today we will start to talk about Agile estimate. This is the first part. Before we start to discuss any particular techniques about Agile estimation, let's first focus on one question. What do we estimate? To answer that question, let's look at an example. Let's say now you need going to airport, the international airport from Opera House, Sydney, right? And you have been asked like, how long will that take you from the Opera House to the airport? Then what your answer will be? You probably will say, wow, it really depends. Because if you're going to take the train, then it may take you about 1 hour, or not 1 hour, maybe 40 minutes. But if you take bus, it may take longer, maybe say 1 hour, not quite sure. But if you take taxi, then it may take you about 15 or 20 minutes, right? So which means your answer really depends on what transportation you're going to use. Then the answer for the estimate will not really certain. So let's say we change the question. Okay. We change the question to from how long to say how far. Then basically the estimation is not about time anymore, it's about distance. Then you probably can give quite certain answer about how many kilometers or how many miles it might be. So which means all the other factors like the transportation, the traffic is not relevant anymore. So it's all irrelevant now. So what do we learn from this example? Basically, it showed us that the time-based estimation is very uncertain. It will be impacted by lots of factors, like who is going to work on that work, which tool is going to be used to solve that problem, blah, blah. So when we need to estimate a work, we should focus on the size of the work. So the size of the work basically is about how big it is. The size of the work. It's not about duration because it won't change by impact a lot of different factors. So when we try to estimate, we need to focus on how big it is rather than how long will that take. So this is the first question about what are we actually going to estimate. The second question is, usually people will ask how much analysis we need to do in order to give an answer about the estimate. We always tend to find a very accurate answer for estimate. So we like to do a lot of analysis work up front in order to find that answer. But actually, a lot of experts also try to find that answer as well. They did a study about that, and they came out a model to explain. So that model, we call it the cone of uncertainty. The model looks like this. The y-axis is the thing you're going to estimate. Let's say it's about size. The x-axis is the time. So basically, you try to solve the problem, and along the way, through the whole life cycle. At the end, you solve the problem and you know exactly how big it is. So based on that study, so at the very beginning, if you try to estimate, it may estimate like this. And along the way, if you start to solve that problem, you eventually find the actual exercise. So the curve of uncertainty like this way. Which means at the very beginning, because of the limited knowledge we have about this problem, whatever how much effort, how hard we work, try to analyze it, I try to find an answer for the estimate, the result is not as we expected. The gap between the estimate and the actual efforts or actual size probably will be 4 times bigger or 1/4 smaller. But when we start to try to solve the problem, when we start to build something, try to solve the problem along the way, when we learn more about that, the estimate will be more and more close to the actual number. So it's like this. So basically, which means if we start to solve a problem, at the end, we will find the better answer for estimate. So what does this tell us? Basically, it tells us we shouldn't waste too much time at the beginning to do analysis, just to try to find the accurate answer. We need to start to try to solve the problem as early as possible in order to learn, in order to gain a knowledge about the particular problem. So that actually we can start to have deep understanding and we can start to have better estimate for this particular problem. So which means we need to find a way to estimate quickly. We need to estimate quickly so we won't actually spend too much time at the very beginning to do the analysis, but we still get enough information to start to work on that. Fortunately, there is a way to do that. Actually, as a human being, we are quite good at that. So let's say we need to estimate the heights of some buildings. We got some buildings here. Say this one. We got this one. We got this very tall one. And we got this one. Okay, so we have different buildings here. We need to estimate how high these buildings are. So if we try to estimate those based on particular measurement, like say how many meters, you need to find a way to measure that. You need to find a particular maybe equipments in order to measure. But if we do this way, like say I give a number for this building, I say this building, the height of this building is 2. I have no reason. I just give it a 2. I just say this is 2 for me. Then I ask you to estimate the height of this building based on that. Then based on that, you probably say, okay, this one, I think it's probably half of it. I give it 1. And this one is probably higher, so probably I give it 3. And this one is higher than this one. I probably give it maybe 4 or 5. I maybe say give it 5. Okay. So you see, through this way, you can actually estimate something very, very quick. It's just based on comparing. It works because based on the study, our human being brain is actually very, very good at comparing, but not really good at measuring. So these estimate techniques, we call it as relative estimate. So the relative estimate, basically, the first thing you need to do is to set a baseline. And the second thing you to do in order to estimate others, you just compare others to this baseline. Through this way, you can estimate things very, very quick and very fast, and give you a rough idea from the whole picture perspective, like how big it is. So this is today's sharing. It is about a relative estimate. What is actually a fundamental idea behind the many Agile estimate techniques? We're going to share more later about particular techniques for Agile estimation. Thank you very much.